Okay, so a new case study for MySocialMedia, and we'll use CQRS, which stands for Command Query Responsibility Segregation, which I think is an interesting model to know about. So MySocialMedia is a company, and it allows people to post images and others to react by using likes and comments. So just, a social media website. And the business wants the following capability. The user should be able to post, like, and comment, and the user should be able to see the total number of likes and comments per post in real time. And there's a high volume of data to be expected because we're going to launch on day one and we need to have crazy high throughput. Now the user should also be able to see trending posts. So there's a lot of requirements, right? How would you do this in Kafka? So think about it for a minute, get to the drawing board and get back to this video. Okay, so let's have a look at a possible architecture using CQRS. So we have three topics that I think are going to be necessary in Kafka: posts, likes, and comments. And post is going to be its own topic, likes its own topic, and comments its own topic. And that's just a decision that I'm making as an architect. So I need to get the user post. So the user is going to create some post and there's going to be a posting service. So maybe he's going to add some text, some links, who knows, some hashtags. And so this posting service on its own will basically create and send all the data when validated to the post topic. Now for my likes and my comments, there's going to be a user likes and comments service, and it's going to be a producer as well. And so the users are going to like and comments, and this will basically send data to my likes and my comments topic. And I could have made it the same topic, but I think the data is different enough to have it for two topics. It's up to you. But here we have an example of a producer that produces to two different topics. Now what we want at the end is a post with counts of likes and comments. But we have to realize that the data comes from all over, right? And it could be multiple people liking at the same time or commenting at the same time. And so if we were doing this against a traditional database, the database would be swamped and there would be some race conditions, etc., etc. So using Kafka, we're able to decouple the production of data to the actual aggregation of data. And for this, we'll use Kafka Streams. So Kafka Streams will basically read the data from the post, the likes, the comments topic, and it will perform some aggregations, such as how many likes for my posts, that kind of stuff, and put this into the post with counts topic. Now, similarly, if we want trending posts, for example, and know which ones are going to be, very liked and very commented, well, we could have a new application, basically a new query using Kafka Streams that figures out the trending post in the past hour. So it may be the post with the most likes or the most comments or a combination of both, and output this with a trending post. And so these are going to be consumed by what I call a refresh feed service, which is a consumer, and a trending feed, which is also a consumer. Could be consumer, could be Kafka Connect sync, could be whatever you want. And finally, put this into our website so that the users can see it. So why is it called CQRS? Well, here on the left-hand side, we have the commands. Commands are basically saying user does this, user likes a comment, that type of stuff. And on the right-hand side, we have the queries, and they're very different from the commands. They're basically decoupled. And that decoupling is what makes this solution architecture scalable for a lot of users. Finally, on the left-hand side, once we have figured out the queries results, we're free to read it any way we want into whatever store we want. And so the website really reads from a decoupled read store as well. And so even if there's a high like or high comment pressure on the website, the read store itself is just fine. Okay? Now, a few comments. This is CQRS in 2 minutes. So this is obviously not enough, but it's give you a small introduction to it. And because the responsibilities are segregated, we can call this CQRS. Now for the post topic, we can see that it can have multiple producer. To me, it should be highly distributed. If I were to choose a key, I would choose user ID because I definitely want to get my post by user ID in order. And I want to get probably high retention of data for this topic. For likes and comments, to me, they're topics with multiple producers. And they should be highly distributed because the data of volume is going to be much greater than the post. So maybe 100 partitions, if it's a big social website, because there's such important feeds. And if I were to choose a key, this time I would choose post ID. And the reason I choose post ID and not user ID is that I kind of want to have all the likes and all the comments for each post to be in the same partition. That will help my Kafka Streams application to make the aggregation properly. And finally, just to comment, The data in Kafka, when it's produced, it should be formatted as events to make things easy. So an event, what is it? It's basically saying user 123 created a post ID 456 at 2 p.m. That's an event. And obviously you need to have more information, what contained the post, etc., etc. Then liked the post and deleted a post. So basically it's an event and it should describe what happened. So that's it. Small introduction into CQRS, but Kafka does help into creating these kind of architectures and solving these problems. Hope that was helpful, and I will see you in the next lecture.